This video is sponsored by PCBWay. Welcome everyone. In this video I'm going to show you how I upgrade my metallurgical microscope and how I create a motorized Z or focusing axis on this microscope. So in one of my recent videos I have already shown this microscope to you, and I showed it how it works and what are its features. So I'm not going to detail those in this video, but I'm going to focus on one thing here in more details, and that will be the Z or focusing axis. So as you can see, we have two knobs here. One is the coarse Z adjustment or focusing, and the other is the fine adjustment. And I don't really know anything from the datasheet of this microscope, and then this guy actually is described in the datasheet, and if you look closer you can actually see a scale on it, and one division on the scale produces 2 micrometers of vertical displacement. So that's a very fine scale. What I think what is more important for us is the large knob, because that will be the knob which I will drive with the stepper motor. So if I turn this knob, you can see that it moves up and down. And then the main mechanism behind this is the following. So probably somewhere in here there is a gear, which is just a simple gear, yes. And then here you can see a rack or a linear gear. So then this is a rack and pinion mechanism. So as I turn this knob, I also turn a gear somewhere inside this enclosure, and that gear climbs up or down along this linear axis. And then what we are going to do with this thing is that I'm going to attach a stepper motor to this, not directly, but by using some pulleys. And then we will convert the steps of the stepper motor to a vertical displacement along this axis. So the driving mechanism consists of 2 pieces. We have this pulley wheel here, which has 60 teeth, and this is a 2GT pulley wheel. It's a very popular piece and you can buy it basically anywhere, but there is one specialty with this thing, and that is its inner diameter. Because if we move back to this, we can see that we have some space here, and then we could potentially put the wheel on that. So this shank, which is just part of the knob, has a 16mm diameter. So then this is also drilled to 16mm, so I can precisely put it on this shank. And then I have this timing belt, which is 220 teeth. And then on the other side of this system, I have this NEMA 17 stepper motor, and this is a slightly more powerful stepper motor. If I remember correctly, it is 0.59 Newton meters torque. And then at the end of the shaft we have a 20 teeth pulley here. So then this pulley, through this timing belt, will drive this 60 teeth wheel, which is then attached to this knob. And due to the fact that this has 20 teeth and then this wheel has 60, the gear ratio is 1 to 3. So then in order to produce a full turn on this wheel has to turn 3 times. And in order to produce a full turn on this shaft, by using the default microstepping settings, which is 200 steps per turn, the stepper motor has to step 200 steps. So then 600 steps, so 200 steps times 3, will produce 1 full turn on this part of the microscope. If you are interested in more calculations regarding the displacement of this knob and the steps of the stepper motor and so on, check the link in the description, because that will lead to my website where I did a more detailed explanation of this in the article that I wrote. So please go to my website. But now let me show you how I mount the stepper motor. So if we return to this mechanism, if we are looking at the z-axis, you can see that this whole part of the microscope moves individually. And then we have this stand here, which is the stationary or static part. So you can see. And then if I would put the stepper motor somewhere and attach it to this static part, that would be an issue, because then the distance between the two center points, one center point is the center point of this wheel and the other is the center point, basically the shaft of the stepper motor, would constantly change. So that would cause issues with the tension of this belt. So then I could do it probably, but with some more difficult tensioner mechanism or something like that. So the better idea is to make the stepper motor move together with this mechanism. So then the distance between the two center points, the driven part and the driving part, which is the shaft of the stepper motor, could maintain the same distance. So then I have to find a way to put the stepper motor somewhere here. And as I already said, we found a place for this wheel, because this wheel will be sitting on this shank here. I will show it to you very soon. But then where to put the stepper motor? So if we look at this mechanism, we can see that this part is basically static, but this part here is not static, because this part slides up and down if I use the fine adjustment knob. It's probably not very well visible in the video because it's a very small displacement, but now as I turn it, this part comes up, and if I turn it in the other direction, then it goes down. So you can see that this gap was increasing and decreasing as I was moving this knob. So then I'm restricted to this very small piece, and I have to keep in mind that this will be exposed as I move down. And I have to move down because that's how I focus on the surface of the specimen which is put on this stage. So as you can see, I have a very small space available. But it's enough. And we are lucky enough that we have these two bolts here. They actually just hold down a spring, which probably belongs to some of the mechanisms, either to this mechanism, which belongs to the fine adjustment, or to this knob, which belongs to the coarse adjustment. So then I can remove these bolts, and I can use their threaded holes inside this piece as a mounting point. So then after a few iterations, I created a 3D printed plastic motor holding bracket, and that looks something like this. So if you see this pattern, then you can see some similarities with this pattern here, because actually I designed it in a way that it can sit there, and actually it can be fitted on top of this part, that it will fully avoid hitting this linear gear here. And then also another thing that we have to consider is that if you look at the front view, you can see that there is not so much space here. And you can see that these are the 4 bolt holes for mounting the stepper motor. So it's very, very tight and calculated space, but it works. So if I go down or if I go upwards, that doesn't matter, because I can stay within the limits. So you can see that we have sufficient gap there, and here we will also be able to maintain a proper distance at this gap. So first I will show you how this wheel is removed and how this pulley wheel is installed. But before proceeding, let me talk about the sponsor of this video, PCBWay. PCBWay is specialized in PCB manufacturing and PCB assembly, and by using their services you can fully customize the board that you want to build. And in addition to this, they also have CNC machining capabilities, 3D printing, sheet metal fabrication, and injection molding. But what is maybe more important is that they have announced their 6th project design contest. And you can submit your project until the middle of next January in 2 different categories: electronic project and mechanical project. And by participating, you have a chance to win valuable prizes. So head over to PCBWay.com and check their competition and participate if you have some exciting projects. So here we see these 2 holes, and I just use a simple plier, plug it in, and then this can come off. And then this is basically just a nut here. It just has this funny head. But then this is the knob. So this shank is roughly 10 millimeter deep, and the diameter is 16 millimeters. It's probably more reliable if I show it. So it's roughly 16 millimeters. It depends on how I rotate it. And then the depth is about 10.6 millimeters. So then I cannot do this because you can see that the bolts would not meet the plastic knob. So I have to do the other way around. And that is this way. So you see that we have a gap here, but you can see that we still have some space here, so it will not cause any troubles. This is just the plastic ring to decrease the friction. So this would not cause any issues. So I just tighten these 2 bolts, and then I put the thing back. So now the wheel is sitting very firmly. I can maybe show it like this. And then I can still rotate this thing. So actually mounting this wheel does not hinder any functions because I can still grab everything here. So then the next step is to remove these bolts. And as you can see, there is a spring there. So that was pushed down by this plate. So now I put this plate back. And then I take this 3D printed part and install it. So I have the bolts already prepared for this, together with the washer there. You can see it's a white colored nylon washer. And then I just align this and screw on the bolts. So now you can see that the plastic part is mounted. It's rigid. And if I show you this part here, you can see that it is not interfering with anything. And here we have the little gap. You can see the light passing through. So then the next step is obviously to install the motor. So I prepared the motor here, so I just remove these bolts so I can mount them on this. So first I put on this timing belt. And then comes the motor, and I make it in a way, or I mount it in a way that the wire looks sideways. And then you can see that I slightly tilt this thing. So now it's almost like fully tensioned, and now I just have to mount it. So I have mounted the motor, and the first thing you can notice is that the belt is very loose, so we will need some tensioning here. And then I also marked the wheels with these tiny lines, these tiny black lines, so we will be able to follow their position. So now we have to make sure that this will be like stiff enough. And for that I invented some kind of tensioner for this particular mechanism. So let me install it, and then you will see how it works. So this is done. So as you can see, this is a stationary wheel, so it is just supported by this bolt here, and then it's pushing the belt this direction, so there. And then this is a bit more smart mechanism. This is also sitting on top of a bolt, but there is an arm here, and then on the other end of the arm here, there is another bolt which supports a similar wheel to this. But then that arm is pulled towards this direction, so towards this wheel with a spring. So then this mechanism, as you can see, it pinches the belt together. So then this should work, hopefully, in a proper way. And then if I move the wheel or the knob up and down, then you can see that everything rotates properly. So now, before moving on, I show you the setup that drives the motor and explain it in half a minute. And then I come back to this view so we can see how this wheel moves and if the tension is enough and so on and so on. So the setup looks something like this. So stepper motor, and then with this cable we go to this DRV8825 stepper motor driver, and that is controlled by my custom-made control panel. I showed this in a previous video, so check that video. But what this can do is it can control any kind of stepper motor in a very flexible way. So I can use the buttons or this rotary encoder to move the stepper motor step by step or with a certain predefined step size. So for example, if I press the button just once and I do, let's say, a button click, or I move the rotary encoder just one click away from its position, then it can make either 1 or 100 or 1000 steps, and so on. And I can even program a so-called ping pong mechanism. So then either by relying on these limit switches or by the number of steps that I feed to this box, for example, in this case, the microscope would move up and down until I stop it. But what is more important for us is to measure the precision of this thing and also measure and convert the number of steps into vertical displacement. So now I move back to that mechanism here because more interesting things will happen there, and I will explain what I do on this control panel, and we will see how the motor moves. So now we are looking at the mechanism again. Please notice that there is a marking here and also here. And then now the stepper motor is set up in a way, or the driver of the stepper motor is set up in a way that it produces 800 steps to make a full turn on its main shaft. So then I will just first instruct the motor to do 2400 steps, because that will be 3 full turns on this shaft, and due to the gear ratio between these two wheels, there should be 1 full rotation on this shaft. So then first let me just move this and see how things work. But since I don't remember the directions, I will just move this slightly so we can see in which direction I should move 2400 steps. So now I'm going to instruct the motor to do 100 steps. So that is 1/8 of this rotation. So if I move in the positive direction on my stepper motor driver, we move upwards. So then I will have to instruct the driver to move downwards, which means I have to give a negative number as an input parameter, and that will give us the right direction. So we will now move downwards 2400 steps. So notice this and this position. For me that looks quite good. I will see it on the editing panel when I edit this video if they positioned properly. But then we can see that this kind of works. I can move the stage up and down with a button, so let me show you how I do that. So if I click the button once, it will be 100 steps. So this is 100 steps. If I keep the button pressed continuously, then it will be whatever steps, but you will see how smoothly it moves. And I can do this in the other way as well. And just a small blooper. You could see that we have lost this guy here. Due to the vibrations, it fell out. But I will fix this. It's not that crucial. It's not like it's attached to the main part of this motor or whatever, but yeah, jokes apart, now it doesn't make any difference because the main bolt is still in the place. And we will see if it starts to slip anyway. Okay, so you could see that this moves very smoothly, and I think what would be funny is that it would be interesting to see if I do a full turn on this shaft, will it really move 15 millimeters up or down? I would rather prefer to move downwards. So then I will attach my dial indicator to this in some reasonable way, and then we will see what the numbers are. So here is the setup. So the dial indicator is hopefully rigid enough, and then you can see that it's showing now minus 14.4 or something like that, or 1.44 to be more precise. And then I'm trying to zero this without moving it too much, so it will eventually become something non-zero. But that's like nearly impossible because it has very rigid buttons. But there we are. So this is at 0. So now I'm attempting to move this with 2,400 steps, and we will see how this thing will behave. So this was more like 18 millimeters, but let's go upwards and we will see if it will end up at the same position. So it should show 0 if everything is correct. So let's see. Yeah, close enough. So that's 140 micrometers. So let's do it once more. So again, it's almost 18 millimeters. And then let's go back. And it almost returned to the same number. So I think that this slight discrepancy here is caused by the movement of the tip of the dial, because if I knock on this, you can see that even this thing has enough flex to kind of change the number on the display. So it's probably due to the lack of rigidity or something. Maybe if I could pick another spot or put the arm on a better place, that would have been better. But yeah, this all looks nice, but I think it would be better to see how this performs if I install my camera on this port, and then I just purely control everything with my stepper motor driver, and then we will see how we can focus, because then obviously there is a reason behind building this on my microscope, and the simple reason is that I want to be able to do focus stacking with this. And you know from my earlier video that I have already built a focus stacking mechanism for cameras, and it works pretty well, and I got quite some feedback from other people that they use it and they are satisfied. So then my next step would be to replicate a same mechanism to make it possible to do focus stacking using a metallurgical microscope. So then let's move to this camera port and see what we see basically when we use the motor. So right now this is what the camera sees through the camera port of the microscope, and the subject is a TCD1201 CCD. So in the center, that gray area, like that gray line across the screen, that is actually the sensor part, and then top of it and under it, those are the auxiliary electronics. And then now I modified the stepper motor driver. So now if everything is correct, then I set the micro stepping to 3200 steps per turn. I did that in order to do a bit more finer steps. So then we will see how this whole thing behaves. So I just start to move in one direction, and we will see how this whole thing moves. So I was moving in one direction. And now I'm moving in the other direction. Maybe if I slow this down, it will be more spectacular. This is real time. So I slow it further down, and now we are going out of focus. So I change the direction, and you can see how it behaves. I went over the focus on purpose. We can go back, but the thing what I want to show you is that this is super smooth, and it is precise enough to make focus stacking. You can see that we are slowly getting more and more focused image. Now you can see the right side is getting more and more focused. So now I actually just move to the rotary encoder and keep moving with that, stepping by 10 steps per click. And if I would move in the right direction, then that would be even better. So let me correct this. So check the image from the right side. So now on the right side we have a sharp area, and now I move 10 steps. And you can see that it slowly moves. And now we are out of focus. Now I go back. And we are in focus in the center again. So now I go back to 1 step per click. And now I'm moving step by step and getting out of focus towards the right side. So the image will be sharper towards the right side, and you will see I'm moving step by step. So I think this step size is more than sufficient for focus stacking. So yeah, this will be quite nice. The only drawback that I noticed here, and that is just simply due to the fact that we are using timing belts, and probably they could be a bit more tight, even tighter than now. There is a slack. So now if I move in the other direction, backwards, and I try to get the center of the picture back to focus, it will take some clicks. So now you have to listen to the clicks. But yeah, it takes quite some clicks to get back to this. But at the end, we are there. And maybe for another demonstration, I will show another object. So let me switch to that. So this chip is a TDA 1060B, if I'm not wrong. And you can see that it's currently not focused. I changed the step size to 40 steps per button click, and now I will just keep the button pressed, so we will see how this can be used for focusing. And I will also change the speed to, let's say, 300 steps per second. And there we go. There is the sharp picture of this object. I changed the lens. And there we go. And now you can see that part of the image is out of focus. So again, I changed the step size to 10, or maybe even 5, and move with the rotary encoder. And now you can see that the center is in focus, and I can move towards the left side to get out of focus. And let's go back. So yeah, this is how it looks. And now I'm moving the stage. So again, you can see that the center is yeah, it's in focus. So then I think we can stop here. We could see this thing in action, and you could see how I built it. If you need some more information, go to my website so you can see more details about the project, some more calculations and more resources, and especially I took a lot of pictures of the building process, so you can use those pictures and data as an inspiration for your project. And then also don't forget to visit PCBWay's website, especially don't forget to visit their design competition. Maybe if you come up with something which is a cool idea, then you can post your project there and you can win valuable prizes. Also, if you like these kind of projects, please consider supporting me on Patreon. Then I can fund these kind of projects and I can build more and more stuff with your help. So I hope that this video was useful to you. I hope you found it interesting and learned something, and see you in the next video.